Good morning. I know you've missed my soothing monotone, so I have some hints for you on the 2018 questions. For number one, we've got our computer output here. If you remember, there's your y-intercept, there's your slope. Don't forget context. You need to mention something about time and the number of customers in line. For your r-squared value, you can look up the canned wording for that on the green sheet packet. For part C, explain why the point is an outlier. So say something that is unique about that point. Include context in your answer. Again, something about number of customers and time. All right, 2018 question number 2. We're kind of working backwards with this question. They gave you the interval. They gave you the interval, and then they're asking you some things about it. The p hat, so we want how many students were in the interval. On your green sheet, there's an example where if you know the margin of error, you can back into n. So somehow or another, we need to know the margin of error for this, and we need to know p hat for this, and then we can just plug all that into this equation here. Again, you got a green sheet packet example. P hat is the middle of the confidence interval, so that'll give us our p hat. And then half the length of the interval is the margin of error. For part B, I think that's there's a name for that type of bias. You can look that up in the green packet. Be sure to include some context in your answer. For C, for part 1 here, don't overthink this. That's an easy question. And then for part 2, you might want to think about splitting that 300 people up into 150 and 150 and thinking about where these answers came from. Those are the only ones we're looking at. We're not looking at any one other than left-handed children to answer part B. For part C, we want at least 3 children are left-handed, so this little red chunk is what we want. That's a binomial CDF question on the calculator. We'll need to do a little bit of subtraction to get that. All right, question number 4. For part A, based on the design of the study, would a statistically significant result allow us to conclude that the new procedure causes a reduction in recovery time? First off, statistically significant just means it's not due to chance. You could think of that as being a low p-value. For causation, the key there is yes, we could conclude that the new procedure is responsible for the reduction in recovery time, and the key there is due to the random assignment to treatments. You need to mention the random assignment to treatments, and you need to mention some context in your answer about recovery time. Part B is a 10-pointer question, full write-up, check conditions, give the null and alternate, etc. Make sure you use the correct notation in your null and alternate. All right, question number 5. A little bit of a tedious question. To find the median, you just need to count everything up. So if I'm looking at school A, there's 45 or so teachers there. There's another, 47 or so there. So I'm up to 90-ish. And then when I get to this one, that'll be the 100-ish. So the 100 teacher is somewhere in here. So 7 to 10 years would be the median for school A. For part B, figure out the total number of years for all those teachers after you added in the other 18 there and divide. For part C, I know when you hear standard deviation, it's easy to start thinking normal model. These graphs are definitely not normal models. They're highly skewed. So part C is just a counting question. You need to go through and figure out how many teachers would be within this much of here. And that's it for number 5. All right, question number 6. This is a hard question. Okay. For part A, this is vocabulary thing. You need to look up type 2 error on your green sheet packet and describe what that would be in the context of this question. For part B here, the sampling distribution X bar for samples of 100 is approximately normal with a mean of 122, standard deviation of 1.5. That means if you look over here, if we had a whole bunch of samples, it would look like this, centered at 122 with a standard with deviation of 1.5, meaning the variation between samples is typically 1.5. And we're asked to find that red region, which would be the reject region, would be that outer 5% because it's a one-sided test here. So we're trying to figure out what this is. So inverse norm to get the z-score and then convert the z-score into a regular value. But the key thing here is they're telling you what a whole bunch of sample means would look like. It would look like that if the null was true. For part C, okay, now they're saying this, we almost never know what the actual mean is, but they're saying, suppose the actual mean actually was 125. Then, in that case, a whole bunch of samples would look like this. They'd be centered at 125. The reject region would be that 124.5 that we got from part B, and so we're trying to figure out what's the chance that we would be in this reject region where the sample mean was more than 124.5. So in part B, we're basing everything off of the null hypothesis. And in part C, somehow or another, we magically know what the actual mean is for the population, and we're basing everything off of that. This is a very tough question. You probably need to look through this a couple